Find the real and imaginary parts u and v of the following functions. I've done a bunch of those on different recordings if you're interested. On this specific recording, I will go ahead and do number 8. And keep in mind here that our z is defined as some function possibly containing x and y, so u is a function of x and y, plus some function I with some function v of x comma y, and so u would be the real part and v would be the imaginary part. And the point behind this question is to figure out what u and v are. So this number 8 sine z, I could rewrite it as sine u plus iv. However, I would need to split the real part from the imaginary part. One way to do this is to use Euler's formula. Now, for some people who don't remember what that is, I could show you how to derive this from scratch. We know that e to the iz, right, the exponential, a complex exponential, can be broken down into cosine whatever that imaginary part is plus I sine that. Okay, and then likewise I could do e to the minus iz, and it will be the same thing, except here I replace z with negative z, and so this becomes cosine minus z, which is the same thing as cosine z, because cosine is an odd function. An even function. And then here I would get sine minus z, but sine is an odd function, so the minus sign would come out and I get minus I sine z. Okay, and my objective is to get sine z. Now notice if I actually subtract these two equations, then the cosine would go away and I would get sine z as a function of the exponentials, and so I would get e to the iz minus e to the minus iz equals I minus I, this would become 2i sine z, and therefore I get Euler's formula that says sine z is equal to e to the iz minus e to the minus iz divided by 2i. So this is the first step, is to split it up into its components in terms of exponentials, so we can deal with it. Okay, this is Euler's formula, and now what I have to do is I do have to work with this so I can split it into the real part and the imaginary part. So what I'm gonna do, I'm gonna replace z on the right hand side of the equation with what it is, which is x plus iy, right? Or u plus iv. Okay, so then we get sine z equals ei, and then x is x plus iy minus e minus I x plus iy all over 2i. Okay, and I will FOIL the I in, so I can collect if possible, so I get e to the ix. Now I times I is I squared, which is minus 1, so this becomes times, right, because addition becomes multiplication, e to the minus y, I times iy, minus e to the minus ix, and same thing here, except there's a negative sign, so this is e to the y, because negative I times iy would be negative I squared y, which is minus 1 becomes plus 1 all over 2i. So this is over 2i and this is over 2i. Okay, now notice what I'm gonna do. I'm gonna collect a few terms here. So I'm gonna bring this and this together, except that I have e to the minus y. So what happens if I could regroup these in a different, so I will replace these with their cosines and sines form the same way I did to show you how to get Euler's formula. So if I do that, I will get sine z to be, so e to the ix is cosine x plus I sine x, okay, and this is multiplied by e to the ix, e to the minus I, we already replaced, and then I'll do the same thing with this is over 2i, the whole thing is over 2i, and this is gonna be the same thing except it's a negative. So as we said, this is cosine x minus I sine x, and the minus sign because you get sine of negative x. Sine is an odd function, so it comes out, so minus sine x, so times e to the y divided by 2i. Okay, now notice, now I can split, now that my I is down there, I could split this into my real part and imaginary part, because if I FOIL, I get e to the minus y cosine x, okay, plus I e to the minus y sine x minus, because let's put the e up front, e to the y cosine x minus minus plus e to the y I sine x. Now don't forget that I have an I in the denominator, and that has gotten to be gotten rid of, because in my form u plus vi, I'm not supposed to have an I in the denominator. So what I'm gonna do, I could multiply this whole equation, I here and I here, so I can get rid of this I down here, because I squared would be minus 1, and if I do that, I will get so now I have a negative half coming from I times 2i, right? So it would be negative half, and then on top I will get minus I e to the y cosine x, and then when I multiply I times I get I squared, which is minus 1, so minus e to the minus y sine x minus I e to the y cosine x, and then the last one will be minus e to the y sine x. Okay, great. Now notice that the I is just a term, not on a power, not in the denominator, so I can pull the terms that have I together. So this guy has I and this guy has I. Okay, and then I'm gonna consider this minus sign sitting out here, so everything becomes plus on the inside, because now everything is negative. So then we get sine z to equal 1/2. Now let's do the real part first. So these two are real, and so these become, if I factor out a sine x, right, I get e to the y plus e to the minus y. Okay, so this is the real part, minus or plus. Now I get the imaginary part, so the I goes here, and then I'm gonna factor the cosine x from both imaginary parts, so I get ey minus plus e to the minus y. Okay, now keep in mind that this half, what I could do, I could pull this half here, so I could put this over 2 and this over 2. And the reason I am doing that is because there's a trig identity that says well, we just sort of shown one now, didn't we? if actually no, that was sine, never mind. But sine, cosine, let me just confirm the identity 1 second here. One of them should be sine hyperbolic and the other one should be cosine hyperbolic. Okay, before I do that, let me just correct one thing here. There has been a sign mistake. When I multiplied this by I, there is no need for a minus sign here. This one turns into a minus because of the minus I squared. This one doesn't, and the last one does. Okay, so technically this carries over to the two terms, to the two imaginary terms, and right. One moment. So this is plus, this is minus, this is minus, right? Because we just multiplied by I, and this here was plus, it's gonna become minus. Okay, fair enough. Now I think it's working out. So we get okay, so we get the I will be sine x this one here will be e to the y minus e to the minus y, which would make it sine hyperbolic y. So this here oops, what happened here? Apologize. Let me pause this and get back. I apologize, sir. This thing, the pad threw me off somewhere different now. Okay, here we go. We're back here. Okay, so yeah, that's yeah, I was correcting the signs. So this is remember, these signs are switching because of that minus sign out there. So so what I could do here, though, I could I need this I to be down here, so I multiply up and down by I, and there's a negative sign that would revert the signs back, so this minus sign is no longer an issue on the second term. So I do get the order of the terms the same way I have them in red. So cosine x, and then I get e to the y e to the y minus e to the minus y. Okay, and wait 1 second. Yeah, there's an I sitting here. Okay, so sorry, this is a minus here because it's the first term. Okay, so when the signs switch, we get e to the y minus. Okay, perfect. So now this is settled. So this guy here, this guy here, let me do this in a different color, or actually, so this guy here is I believe cosine hyperbolic. Yes, so this is cosine hyperbolic y, and this guy here is sine hyperbolic. So this becomes, including the half, of course, sine hyperbolic y. So my final answer then, finally, we would get sine z to be sine x cosine hyperbolic y, this is the real part, plus I cosine x sine hyperbolic y. And so thus u is the first part, sine x cosine hyperbolic y, and v is cosine x sine hyperbolic y. U is the real part, v is the imaginary part, and this concludes this question on how to turn sine z into its real and imaginary parts.